Welcome to lecture series on matrices. In the previous session, we have seen the fundamentals to matrices. So, as matrix is a singular and matrices is a plural word, so just we will recap the earlier session so that we will continue further. So, matrix is a rectangular array of numbers, symbols, or functions in rows and columns. So, the horizontal lines will denote rows and vertical lines denote columns. So matrices consider horizontal rows as well as vertical columns. Now, order of the matrix. Order of a matrix. If it is a matrix is having m rows and n columns, then the order of the matrix in the matrix is said to be of order m by n, or is a m by n matrix. Then number of elements in a matrix. Number of elements in a matrix. If A is a matrix of order m by n, then the number of elements in A is equal to number of rows multiplied with number of rows multiplied with number of columns. Number of columns. The general matrix, if A is a matrix with m rows and n columns, then the general matrix A with order m by n is given by A11, A12, A1n, A21, A22, A2n, so on, AM1, AM2, AM3, AMN. So AN1 represent element in the first row and first column, first row and second column, first row and nth column. So this is mth row and first column, this is mth row and nth column. This is how we can represent any matrix of m by n order in terms of the coefficients A11, A12 likewise. Now, construction of matrices. A matrix is constructed if we have information about what is the order of the matrix and what is the ijth entry of the matrix. Means Aij should be given. Here Aij is nothing but entry in the ith row and jth column. So if Aij is given and order of the matrix is given, then we can construct the matrix of required order and required type of elements. So this is all about the previous session. So this all we have learned. Now we will see the next concept, which says types of matrices. So matrices are basically classified based on what are the elements and what is the order, depending upon the order of the matrix, or maybe the elements forming the matrix. Matrices are classified in so many ways. Basically, they are classified into two categories. One is rectangular matrices, another one is square matrices. So as we can see, in case of rectangular, the dimensions, height, length and breadth will not be same. Therefore, in case of rectangular matrix, number of rows is not equal to number of columns. If number of rows and number of columns are different, then we can call it as rectangular matrix. In case of square matrix, both rows and columns are equal. Number of rows equal to number of columns. In that case, we call that matrix as square matrix. So we can see some special classes of rectangular matrix. They include row matrix and column matrix. What row matrix is? It is row means it is having single row. A matrix having single row, but any number of columns. Any number of columns is called a row matrix. Likewise, column matrix is nothing but it is having a single column, and any number of rows. So this is about special cases of rectangular matrix. So we can see example of what is a row matrix. I am considering matrix A as 1, 2, 3, 4, 5. So we can observe number of rows is 1 and number of columns is 5. So this is matrix of order 1 by 5. For a column matrix, we can see I am taking B as it is having only single column. So we can see a column is 1 and rows are 5. So this is 5 by 1 matrix. So this is how we can give example for row matrix and column matrix. So any rectangular matrix can be having number of rows is not equal to number of columns. I am taking an example for that. I am taking D matrix T as 4 by 2 matrix. So number of rows will be 4. Number of columns will be 2. This is 4 minus 3 root 2 0. So this is a matrix of order 4 by 2. Here number of rows is 4, number of columns is 2. So they are not equal, therefore it is a rectangular matrix. Now seeing what are the square matrix. As I said, number of rows is equal to number of columns, then that matrix is called a square matrix. So there are special some terms associated with square matrices. We can see I can write the general square matrix of order n by n is so a n by n. So it is called as a matrix of order n by n or a matrix of order n. We can simply call order n. The general matrix of order n by n is given by a11, a12, a1n, a21, a22, a2n, an1, an2, an. We can observe number of rows is equal to number of columns because rows are m and columns are also n. Now the elements along which, as I have said, any entry in the matrix is given by ij. So this is the element in the ith row and jth column. If I plus I equal to j, then that entry is called diagonal entry, because we can draw diagonal line for a square matrix. It is a diagonal entry. The entries along the diagonal is called diagonal entries, and above diagonal they are called upper diagonal elements. Upper diagonal elements. Upper diagonal elements. The elements below the diagonal are called lower diagonal elements. And the elements for which I is equal to j are called as diagonal elements. We can observe for diagonal elements I is equal to j. And for upper diagonal elements I is less than j. Upper diagonal elements. And for lower diagonal elements I is greater than j. So these are some terms associated with the square matrix. So what are the diagonal entries? Upper diagonal and lower diagonal entries. Now we will see special classes of square matrices, what they may be. So one case is diagonal matrix. So what is a diagonal matrix? It is a square. Firstly, it is a square matrix in which all non-diagonal entries are 0. Non-diagonal means Aij such that I is not equal to j. Those entries for which I is not equal to j, they are called as non-diagonal entries. So in case of diagonal matrix, it is a square matrix in which all diagonal entries are 0. Non-diagonal entries should be 0. So we can see the example. So I am writing D as 0, minus 5, 8, root 2, As we can see, it is having 4 rows and 4 columns. It is a 4 by 4 matrix, and hence it is a square matrix. You can observe the non-diagonal entries, means upper diagonal entries as well as lower diagonal entries, elements are 0. So we don't restrict the diagonal elements. So they may be 0 or non-zero. Diagonal entries are not restricted. So these are called diagonal matrices. So in diagonal matrix, we are also having some special cases. So the special case of diagonal matrix is a scalar matrix. A matrix, to be a scalar matrix, it should be a diagonal matrix. Diagonal matrix in which all diagonal entries should be equal or equal. So basically it is a diagonal matrix. Diagonal matrix means it is a square matrix in which all non-diagonal entries are 0. For diagonal matrix to be a scalar matrix, all diagonal entries are equal. So we can see example. So I can take a matrix E as 5, 0, 0, 0, 5, 0, 0, 0, 5. So we can observe first it is a square matrix of order 3, or it is a 3 by 3 matrix, and all 9 diagonal entries are 0, and we can observe all diagonal elements are same. So this is an example for a scalar matrix. Now for a particular case of scalar matrix, we are having one more matrix that is called identity matrix. So for a matrix to be identity matrix, it should be a scalar matrix in which all diagonal entries should be equal to 1. So for a scalar matrix to be identity matrix, its all diagonal entries should be 1. So we can see that generally the identity matrix of order n is denoted by In. So I am taking for n is equal to 3. This is I3. It is a identity matrix of order 3. So 1 0 0 0 1 0 0 0 1. So we can observe this is a first it is a diagonal matrix, then it is a scalar matrix, and then all diagonal entries are 1. Therefore it is identity matrix of order 3. So this is how we can classify different matrices. So basically they are classified as rectangular and square matrices. It is based on number of rows are equal or not. If they are not equal, they are called as a rectangular matrix. If they are equal, they are called as square matrix. So in case of rectangular matrix, we are having some special cases. One is row matrix, one is a column matrix. Row matrix, it is having single row. Column matrix, it is having single column. So any matrix which is not a row matrix, it is not a column matrix, but it is a rectangular matrix, can be defined such that number of rows is not equal to number of columns. So this is how we can give an example for rectangular matrix, which is not a row matrix, which is not a column matrix. Now coming to square matrix. So as I said, the number of rows equal to number of columns, such matrix is called as a square matrix. So the general square matrix of order n. So means order n means number of rows equal to number of columns is equal to n. It is given by a11, a12, a1n, a21, a22, a2n, and an1, an2, ann. Now observing this general matrix, so we can draw a diagonal. Along that, if suppose we are having a ijth entry element in the ith row and jth entry as aij, suppose I is equal to j, then that line, so those elements are called as diagonal entries or diagonal elements. So along that we can draw a diagonal. So these are called diagonal elements. The elements above the diagonal are called as upper diagonal elements, and elements below the lower diagonal elements are called as lower diagonal elements. So for upper diagonal elements, we are having I is less than j, means aij in, if suppose aij is the entry in the ith row and jth column. If I is less than j, then those elements are called as upper diagonal. If I is greater than j, then those elements are called as lower diagonal elements. So seeing some special cases of square matrix, one special case is diagonal matrix. So for a matrix to be a diagonal matrix, it should be a square matrix. It should be a square matrix in which all non-diagonal elements are 0. So we can observe aij is equal to 0 for I not equal to j. Such a matrix is called as a diagonal matrix. So this is an example for a diagonal matrix. Now we can see a special class of diagonal matrix. So that will be a scalar matrix. So for a matrix to be a scalar matrix, first it should be a diagonal matrix. So we are taking a diagonal matrix in which all diagonal entries are equal. if suppose we are having a diagonal matrix such that all diagonal entries are equal, then such a matrix is called as a scalar matrix. So this is an example for a scalar matrix. Now, so as a particular case of scalar matrix, if suppose all the diagonal entries are equal to 1, so we are having a scalar matrix such that all diagonal entries are equal to 1. Such a matrix is called as identity matrix, and if identity matrix is of order n, it is denoted by in. So this is an example for identity matrix of order 3. This is all about classification of matrices. We can write in terms of flow diagram. Types of matrices: rectangular, square. In case of rectangle, we are having row matrix, column matrix. In case of square, we are having diagonal matrix. So in diagonal matrix, again we are having a scalar matrix as a particular case, and as a particular case of scalar matrix, we are having identity matrix. This is a particular case. Diagonal matrix particular case is scalar matrix. Particular case is identity matrix. This is how it is denoted by in. Usually diagonal matrices are denoted by D. So if suppose D is a diagonal matrix with entries D1, D2, Dn, so it is an n-by-n matrix such that all entries are 0, then this can be denoted as D is equal to D1, D2, so on Dn. So if suppose we write D is equal to D1 to Dn, then it should be understood that this matrix is a diagonal matrix with diagonal entries D1, D2, Dn, D1, D2, so on Dn. So this is how we can represent diagonal matrix. So this is all about classification of matrices. Now we can see next concept, which is the equality of matrices. Now we will see equality of matrices. So when the matrices are said to be equal, equality of two matrices. For comparison, we need to. So let's consider two matrices. If suppose A and B are two matrices, then they are said to be equal. If they should follow some conditions. First one is they should be of same order. Means the order of A should be equal to order of B. Suppose A is a matrix which is given by Aij. If it is of order m by n, then B should be also m by n matrix. So order of both the matrices should be same, means the number of rows in first matrix is equal to number of rows in second matrix, number of columns in first matrix is equal to number of columns in second matrix. And second condition is that if suppose Aij is the element in the ith row and jth column, and Bij is the element in the ith row and jth column of B, then they should be equal for all I and j. Means the corresponding elements of A should be equal to the corresponding elements in B. Therefore, we can write it as element in the ith row. If suppose Aij is the element in the ith row and jth column of A, then that should be is equal to element in the ith row and jth column of B. So for all I and j, they should follow for all I and j. So suppose we are having A is equal to 1, 2, 3, 4, 5, 6, and B is equal to 1, 3, 2, 4, 6, 5. So we can observe these two matrices are having order 2 by 3. So number of rows 2, number of columns is 3. So both of them are having same order. So this condition holds. And second condition should be Aij is equal to Bij for all I and j. We can see A11 is equal to B11 and A12 is equal to B12. But A13 is not equal to B13. So if this fails for at least one element, then those two matrices are not equal. Therefore, A and B are not equal matrices. So to check, we should observe each and every matrix of each and every element of A with the each and every element of B. If at least one element which is not equal to other element of B, then they are not equal matrices. Therefore, for two matrices to be equal, they should be of same order, first condition, and the corresponding entries in both the matrices should be equal. So this is about equality of two matrices. So we can see one example so that it is clear. Two three zero one. A is equal to 2301 and B is equal to 2301. So we can observe both are having same order and same elements. So A11 is 2 and B1 is 2. A12 is 3 and B12 is 3. A21 is 0 and B21 is 0. A22 is 1 and B22 is 1. So therefore A and B are equal matrices. We are equal matrices. But if suppose I take 3201, A as 3201 and B as 2301, we can observe the elements are same, but the positions are not different. So A11 is not equal to B11, therefore A and B are not equal matrices. So this is how we will see whether two matrices are equal or not. Sometimes what they will give is, they will mention A and B are two equal matrices, and then find the coefficients which are left in A or left in B. So we can take example so that it will be clear. Example, if x plus 3 equal z plus 4 2y minus 7 minus 6, a minus 1 0, b minus 3 minus 21 0, this is equal to 0 6 3 5 minus 2 minus 6 minus 3 2c plus 2 2b plus 4 minus 21 0. So they have given, suppose I take this as A matrix, this is a B matrix, they have given A is equal to B, then we have to find the values of A, B, C, X, Y and Z. So because they have just given A and B are equal matrices, then find the values of the unknowns A, B, C, X, Y, Z. So as the condition is given A and B are equal matrices, therefore first we have to check whether they are having same order or not. They are having same order. So when they are equal means the corresponding element should be equal. So A11 should be equal to B11, A12 is equal to B12, A13 is equal to B13, A21 equal to B21, A22 equal to B22, A23 equal to B23, A31 equal to B31, A32 is equal to B32, A33 is equal to B33. So just we will compare x. Therefore x plus 3 is equal to 0, z plus 4 is equal to 6, 2y minus 7 is equal to 3y minus 2, minus 6 is equal to minus 6, a minus 1 is equal to minus 3, 0 is equal to 2c plus 2, b minus 3 is equal to 2b plus 4, minus 21 is equal to minus 21, 0 equal to 0. So as they are giving identities, we will not take these things. So we don't consider these equalities, and we will consider only those equalities which involve variables. So x plus 3 is equal to 0 implies x is equal to minus 3, z plus 4 equal to 6 implies z is equal to 2, and 2y minus 7 is equal to 3y minus 2 is equal, implies this is minus 7 plus 2 is equal to y. So y is equal to minus 5, and a minus 1 is equal to minus 3 implies a is equal to minus 2. This is 2c plus 2 is equal to 0 implies 2c is equal to minus 2, c is equal to minus 1, and this implies b minus 3 is equal to b minus 3 is equal to 2b plus 4. This is minus 3 minus 4 is equal to 2b minus b. B is equal to minus 7. So we got a is equal to minus 2, b is equal to minus 7, c is equal to minus 1, x is equal to minus 3, y is equal to minus 5, and z is equal to 2. So this is how we will find the unknowns given in a matrix. So given the condition that those two have equal matrices, this is how we will use the concept of equality of matrices. We will see one more example. Find the values of A, B, C and D from the following equation. So 2a plus b, a minus 2b, 5c minus d, 4c plus 3d is equal to 4 minus 3, 11, 24. So they have given these two matrices are equal, then we have to find the values of a, b, c, d. So just we will equate the corresponding elements and we will find a, b and c, d. So equating a1 with a11 equal to a11 should be equal to b11, a12 should be equal to b12, a13 should be a21 is equal to b21, and a22 should be equal to b22. So a11 is 2a plus b, and b11 is 4, a12 is a minus b, a minus 2b, b12 is minus 3. So we got two equations, and from these two, 5c minus d is equal to 11, 4c plus 3d is equal to 24. So we write this equation for a. So a is equal to minus 3 plus 2b. Just putting a is equal to this in the first equation. 2 into minus 3 plus 2b plus b is equal to 4. Minus 6 plus 4b is equal 4b plus b is equal to 4. So this is 5b, 4b plus 5b. 5b is equal to 4 plus 6. So 5b is equal to 10. B is equal to 2. So we got b is equal to 2. So just b is equal to 2. Putting in this equation, so a equal to minus 3 plus 2 to 2 is 4. This is a is equal to 1. So we got a is equal to 1 and b is equal to 2. So considering these two equations, we can find c and d. So I am writing this equation for d. So d is equal to 5c minus 11. Putting d value in this equation, 4c plus 3 into 5c minus 11 is equal to 24. 4c plus 15c minus 33 is equal to 24. That is 19c is equal to 24 plus 33. 57. So 19c is equal to c is equal to 57 by 3. 19. This is equal to 3. So putting c is equal to 3 in this equation, d is equal to 5 into 3 minus 11. This is 15 minus 11. This is equal to 4. Therefore we got d is equal to 4 and c is equal to 3. So likewise we find the values of a, b, c and d. Therefore a is equal to 1, b is equal to 2, c is equal to 3 and d is equal to 4. This is how we can find the values of unknowns. Now we will see some exercise questions. Exercises. So we have some questions. It says find the values of x, y and z from the following equations. So first one is 4, 3, x, 5 is equal to y, z, 1, 5. So second one is x plus y, 2, 5 plus z, x into y is equal to 6, 2, 5, 8. And third one is x plus y plus z, x plus z, y plus z. This is equal to 9, 5, 7. So they are given. We have to apply the concept of equality of matrices. So these two matrices are equal, therefore the corresponding entry should be equal. This implies y is equal to 4. So z is equal to 3 and x is equal to 1 because y is equal to 5 is already followed. Therefore this has values of x, y and z. For the second case, we are having both side 2 by 2 matrix and they should be equal, means the corresponding entry should be equal. This implies x plus y is equal to 6. So 2 is equal to 2 identity, we don't consider. 5 plus z is equal to 5. And so x into y is equal to 8. So z is equal to, this gives 5 plus z is equal to 5 gives z is equal to 0. So we don't get x and y here. We can write this equation for x as x is equal to 6 minus 5. So putting x is equal to 6 minus 5 in this, 6 minus 5 into y is equal to 8. So this is 6y minus y square is equal to 8. We can write it as y square minus 6y plus 8 is equal to 0. So it means 2, 4. Y square minus 2y minus 4y plus 8 is equal to 0. This is y minus 2 minus 4. Y minus 2 is equal to 0. Y is equal to 2 and y is equal to 4. So y is equal to 2 and y is equal to 4. We will put this in this equation. If we put y is equal to 2, for y is equal to 2, we get x into 2 is equal to 8. So x is equal to 4. For y is equal to 4. So this is x into 4 is equal to 8. So x is equal to 2. That's the root we got. Z is equal to 0. X is equal to 2 and y is equal to 4. One case. And z is equal to 0. X is equal to 4 and y is equal to 2. So just we can observe z is equal to 0 will give equality. X into y means 4 2 say 8 and this is so both will follow the same. Therefore we are having two cases when z is 0, x is 2 and y is 4 for one case, and z is 0, x is equal to 4 and y is equal to 2. So these two are the two cases. So we can observe it is a column matrix. It is having 3 rows and 1 column. Just we will compare the corresponding entries. X plus y plus z is equal to 9, x plus z is equal to 5 and y plus z is equal to 7. So y plus z is equal to 7. Just we will put in this equation x plus 7 is equal to 9. X is equal to 9 minus 7 is 2. So we know x is equal to 2. Just we will put x is equal to 2 in this equation. So 2 plus z is equal to 5. Z is equal to 3. We put z is equal to 3 in this equation. Y plus 3 is equal to 7. Y is equal to 7 minus 3 is 4. So therefore x is equal to 2. Y is equal to 4 and z is equal to 3. So this is how we can find the unknowns provided the given matrices are equal. We have some more examples on the equality of matrices. The next example says find the values of A, B, C and D from the given equation. A minus B, 2A plus C, 2A minus B, 3C plus D is equal to minus 5, 0, 30. Just we will compare the corresponding entries and we will find the values of A, B, C, D. So A11 is equal to A, B11, A minus B is equal to minus 1, 2A plus C is equal to 5, 2A minus B is equal to 0, 3C plus D is equal to 13. So 2A minus B is equal to 0 gives B is equal to 2A. So just putting B is equal to A in this equation, A minus 2A is equal to minus 1. This is minus A is equal to minus 1, A is equal to 1. So putting A is equal to 1 in B is equal to A. So this will give B is equal to 2. 2 into 1 is equal to 2. So B is equal to 2. We got A is equal to 1. So putting A is equal to 1 this equation, 2 into 1 plus C is equal to 5. C is equal to 5 minus 2. So C is equal to 3. So putting C is equal to 3 in this value, 3 in this equation, 3 into 3 plus D is equal to 13. D is equal to 13 minus 9. This is 4. D is equal to 4. So therefore we got A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4. This is how we can find the values of unknowns using the concept of equality of matrices. Now we have next example as next question is question from exercise only. A is equal to matrix of order m with the ij entry A m A I J, which is square matrix. If first option is m is less than n, second option m is greater than n, third option m is equal to n, D none of these. So for a matrix to be square matrix, both number of rows and number of columns should be equal. So for square matrix, number of rows equal to number of columns. This implies m is equal to n. So option is option C. So we can find a solution for this. So next question is, this is also from the exercise only. which of the given values of x and y make the following pair of matrices equal. First matrix is 3x plus 7, 5, y plus 1, 2 minus 3x is equal to 0, y minus 2, 8, 4. They are given two matrices for which values of x and y, though these two matrices will be equal. So options are option A, x is equal to minus 1 by 3, y is equal to 7. B is not possible, means they will never be equal. And third one is y is equal to 7, x is equal to minus 2 by 3. And fourth one is x is equal to minus 1 by 3, y is equal to minus 2 by 3. So they are asking when these two matrices will be equal. For which values of x and y these two matrices will be equal. Therefore, we will assume that these two matrices are equal and we will find the values of x and y. So taking 3x plus 7, 5, y plus 1, 2 minus 3x is equal to 0, 8, y minus 2, 4. So equate the corresponding entries. 3x plus 7 is equal to 0, 5 is equal to y minus 2, y plus 1 is equal to 8, 2 minus 3x is equal to 4. So y plus 1 is equal to 8 plus y is equal to 7. So if I put y is equal to 7, this will hold. From this we will get x is equal to minus 7 by 3. So if suppose I put this as 2 minus 3 into 7 by 3, minus 7 by 3. This will give 2 minus 3x is equal to 8. So 3x plus 7 is equal to 0. So x is equal to minus 7 by 3. 2 minus 3x is equal to 8. 3x means x is minus 7 by 3 from this. So this will give 2 plus 7. This is equal to 9, but it is we are getting 8. So this is not equal to 8. Therefore, these two matrices will never be equal. So it is not possible that these two are equal. Not possible. Option is option B, not possible. This is how we can perform. What they are given is for which values of x and y these two matrices will be equal. So we assume that those two matrices are equal and we will compare the corresponding entries. So from this case we are getting x is equal to minus 7 by 3. So if it is true, then this entry should also be, it also should work. So this is, sorry, so this is 2 minus 3x is equal to 4. So this will give 3x is equal to 2 minus 4. This is minus 2. X is equal to minus 2 by 3. We are getting two values for x. X is equal to minus 2 by 3 and x is equal to minus 7 by 3. Therefore, x cannot be having two values. Therefore, it is not possible that these two matrices are equal. This is how we do the comparison of matrices with the help of concept of equality of matrices. The next question, which is also from the exercise. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is option A is 27, option B is 18, option C is 81, option D is 512. So they are asking the possible number of matrices of order 3 by 3 with each entry either 0 or 1. So we know that general matrix of order 3 by 3 is given by A11, A12, A13, A21, A22, A23, A31, A32, A33. So they are giving, so we can take everyone as 0 or 1. This is also for 0 or 1, 0 or 1. Any entry can be taken as 0 or 1. Therefore, each entry is having two choices. So two choices for A11, two choices for A22, and two choices for A13, A21, A32 also 2, A23 is also having two choices, A31 is also having two choices, A32 is also having two choices, and A33 is also having two choices. Therefore, total number of choices is equal to possible matrices is equal to how many choices are there, how that much matrices should be there. This is equal to 2 into 2 into 2. This is 9 times because we are having 9 entries. This is 2 power 9. This is equal to I think 512. So therefore the number of possible elements of matrices of order 3 by 3 with each entry 0 1 should be equal to 512. So this is how we can find the number of possible matrices. So this is all about the concept of equality of matrices and some exercise problems related to that. We will see the next concept, operations on matrices, in the upcoming class. Till then, keep watching. Thank you.